Hi, my name is Omar Kamal. I'm from Team 5 and I would like to present our embedded project. So imagine this scenario that for some reason you forgot something important at home, and for some reason a family member in your home is not free to give you that item. So our proposal is we made a robotic servant that is instructed to detect you entering the house, and it moves in a preset direction. It may have obstacles or it may not have obstacles, and its job is to take the item and deliver it to you, and it stops at detecting your motion.
Okay, so over here we have the actual servant. To start off, we have the skeleton of the mini car, then we have the breadboard, then we have the other circuitry. Over here we have the edge bridge, which drives power to the rest of the parts of the car. And then we have the actual Arduino board, which is responsible for all of the logic of our code. It has the inputs from the two sensors going into it to control the motion when the car is moving forward, when there's an obstacle, when to go back to moving forward, etc. And we have the wires, the output wires, which drive the output back into the edge bridge. So I think that's it.
My name is Khalid Mohammed. I'm going to be explaining the code part of our embedded systems project. The code part is built on these three Boolean variables: blocked from the left, blocked from the front, and trajectory. Blocked from the left becomes true when the sensor of our car on the left side becomes activated. The same goes with the front, but the trajectory one is the tricky one. When the car is basically trying to get around an object, the trajectory becomes true. And you will see here how we make the trajectory become true. So we made 8 if conditions for 8 Boolean logic statements for these 3 Boolean variables. As you can see here, when they are all false, the car moves forward, so the car isn't blocked from any direction, and it isn't trying to get around any object, so it simply just moves forward. However, when it's blocked from the front, as you can see here, it's true. The car tries to move around the object, so the trajectory gets set to become true, and the car moves to the right. When the car isn't blocked from the front, and it isn't trying to get around some object, and it's blocked from the left, we don't really care, because we're not trying to get around an object, so we just move forward. However, when it's blocked from both directions, we also don't care about the left direction, because it doesn't really matter to us. We're trying to get around an object, so we just move to the right. However, when every time we move to the right, we are trying to get around an object, so we set the trajectory to true. And as you can see here, so when the car just moved to the right, the surface that was blocking us from the front is now on our left, and this condition is the one that's dominant. So it's the trajectory is true, we're trying to get around an object, and we're blocked from the left. So when this happens, we just simply move forward as we're trying to get around the edge that's blocking us. Of course, if that didn't happen, like if there's another surface that's blocking us from the front right after we took a right, then we're going to keep moving to the right, because we're going to try to get around the surface that's blocking us from the right again. And if we're not blocked from the left anymore, this means that we have already passed what was already blocking us. So we move to the left in order to get back to our normal trajectory. And for the last one, when we're not getting blocked from anywhere, it's the same as this one, because we don't really care if we're blocked from the front after we've corrected our trajectory.
I'm going to explain how the integration code works. So to start, we have our Boolean here. This one lets us know whether we should be moving or not. This is the timeout. It is a long, just to give us more room for testing. it is the rough estimation we need for the car to reach its destination. This is just an integer to tell us where the car is going. The pin modes here, these first four are one for each wheel of the car, and pin modes 5 through 7 are the inputs of the sensors. 7 is the front sensor, 6 is the side sensor, and 5 is the door sensor. So the way the car works is when you give an output of high, it basically lets the wheel move. And wheel 8 is the bottom right, wheel 9 is the top right, wheel 10 is the bottom left, and wheel 11 is the top left. So the way the car turns around is by switching 2 of the wheels off and while keeping the other 2 on. So if you want to turn right, you switch off the bottom left 2, and vice versa for left. And here we have a method for stopping the car. So what we do in the loop is we initialize a t here. This t is basically a rough guess on how much it takes to turn the car by 90 degrees. The values here are the input values of the sensors. They are infrared sensors, so active low which means they are active low. When they return a 0, means they see something. So we check here if not value 3, which is the door sensor, and we haven't timed out yet, we set our catch-up function, our catch-up boolean, which is the whether or not I should be moving, to true. The other 2 booleans are set to be equal to the inputs from the other one. Like blocked forward is value 1, which is from sensor number 1. Value 2 is from sensor number 2, and it checks the block whether or not I'm blocked on the left. In the middle is basically the code and the logic, which will be explained later. And in the end, we reduce the timeout in long, and we check if it's equal to 0. We tell the car to stop and not work again.
اكشن.
done خلاص.